All right, this week we're doing arithmetic and geometric sequences. So we're going to do arithmetic today. Guess that's how you say that word. We'll do geometric tomorrow. We'll review them. We'll do a little quiz on them on Friday. And then we'll move on to the next unit next Monday. I think we're going into logs next week. Our exponentials. We're doing exponentials and then we're going to do logs. All right, so our warm-up today says the following list of numbers is an example of an arithmetic sequence. So we have 1, 3, 7, 15, 31. You were talking to each other, and it wanted to know what was the pattern, what was the rule that we could then find the next number in the sequence. So who has an idea of how one each became the next paragraph?
Okay, well, I was going to start with their own odds.
Okay.
And then with every number you're adding by, that number that you're adding by is double. So 1 plus 2 is 3. If you double 2, 3 plus 4 is 7. Double 4, 7 plus 8 is 15. And then double 8, 15 plus 16 is 31.
Okay. That's one way to do it. That's not the way I thought of, but it works. Yeah, no, that's good. Awesome. Renee, what'd you say? Powers of 2? What do you mean? Oh, like what you're adding by? Okay. Aubrey? Yeah, that's what I saw. Yeah, so you were all right. You all found a pattern. It was working every time. Yeah, the pattern I saw was you're doubling the number and then adding 1 to it. So the next number is 63. Yeah. Yeah, so you're double, and then plus 1. That's what I saw, but that was awesome. There were 3 different ways that y'all pointed out that all technically meant the same thing. Good. Okay. So looking at our list over here, okay, so that was one arithmetic sequence, the 1, 3, 5 that's listed over here on list 1. Here's a couple of other examples. There's list 2, there's list 3, okay. Looking at the list, how do they relate to each other? So we already know list 1, you're doubling and adding 1. What's happening with list number 2? 15, 10, 5, 0, -5. We're subtracting the same thing each time, right? List 3, don't freak out because it's a fraction. So 3, 7 over 2, 4, 9 over 2. What is 7 over 2, by the way? It's just 3.5, right? And then you got 4, and then 4.5, and then 5. So what's happening there? So here we're adding by a half, right? So 1, 3, 5, 7, 9. Here we were adding 2. Oh, it's not the exact same one. It's close to it. It's our odds. List 2, we subtracted 5 each time. Goodness. List 3, we added 1/2, or we can say we added 0.5 each time we move forward. Okay. So I've told you this is an arithmetic sequence, and we've seen how they work. So now can you kind of put in your own words what is an arithmetic sequence? So talk to your partner, try to put it into your own words about what exactly we're going to be looking at today. So there is a pattern that's following. It is consistent. It is linear. Okay. It's a sequence of numbers in which each consecutive pair of numbers has a common difference. So notice on those the ones in our table, we added or subtracted the same thing each time. Right? It's the adding and subtracting that makes it arithmetic. So an arithmetic sequence is, so you have your own words. Now here's like the math definition underneath that. An arithmetic sequence is a sequence of numbers in which each consecutive pair, that means one after another, has a common difference, which we're going to use the letter D in our formulas that we're going to be working with today. We good? We got it down? All right. So we have 2 different formulas that we're going to kind of create here before we work with them, okay? So consider the sequence 1/3, -4/3, -3, -14/3. Again, don't freak out because it's a fraction. You're just fine. Okay. The first term, which we're going to use a sub 1, is how we say that out loud. What is the first term of the sequence? It is 1/3. Good. What is the common difference each time? Look at the very first one. How did 1/3 become -4/3? What did you subtract? Because it went down. We went down 5/3. Do we agree with that? We good? So our difference is a -5/3 because you subtracted the number from it. So using our first term and our common difference, we're going to write an equation to represent this arithmetic sequence. So we say a sub n, so that means to find any term in this sequence. I could use this formula to get the 100th number. Okay, so to find any number in this sequence, I have to use my first value, which is 1/3. I'm going to add to that n minus 1, and then times our d, which in this case is -5/3, like that. So n is which number in the sequence we're looking for. So if I want you to find the 12th term, the n is 12. Okay. If I want the 6th term, well, if you have the first 4, it might just be easier to do the pattern 2 more times, right? But if I want the 100th term, you don't want to keep doing that pattern 100 times. You're going to need a formula to get there quicker. Okay, so now let's use this to find the 15th term of this sequence. So my n is 15. So we're going to have a sub 15 equals our first term plus 15 minus 1 times -5/3. So when we plug that in, what do we get? That becomes 1/3 plus 14 times -5/3. Ugh, can't talk today. Okay, Jude got -23. I'm going to need like 2 more people to confirm, because we know calculators are silly if you make a small mistake. Yes, Tucker confirms. Anybody else? They could have made the same mistake. One more person. -23. There we go. Yes, it is correct. It is -23. Good. All right. We can also use this equation to go backwards. What term is going to result in the value of -163? So you don't know what term it is. So whatever term, we don't know n, is going to equal the first term plus n minus 1 times -5/3. So here we're going to work backwards. So we're going to distribute, add, subtract. Can you do it? Can you figure out n? Yes, you can. I didn't leave a lot of room there, did I? So this is going to be 1/3 plus, what is that, -5/3 plus 5/3. There should be an n. Boop. What? Okay, I lost you. Let's go back. I don't want to lose you. I am distributing. There should be an n right there. I'm distributing -5/3 to n minus 1. So here, -5/3 times -1, I'll do that first, is a +5/3. That helps because all my fractions are next to each other. -5/3 times n is -5/3 n. Combine like terms, what is 1/3 plus 5/3? 6/3, which is what? 2. That's nice. That's better to work with. Sorry, the spacing is small. So we have negative 163 equals 2 minus 5/3 n. Now what are you going to do? Subtract the 2. Negative 165 equals negative 5/3 n. And how do we get rid of that fraction? We multiply by the reciprocal. So we're going to multiply both pieces by negative 3/5. You want n to be a positive, so you're going to do a negative times a negative to make your n positive. Yeah. So what is negative 3/5 times negative 165? We can't be scared of fractions, guys. It is 99. So it is the 99th term in the sequence. So we can use our equations to go each direction. We can find out a certain term in the sequence, or if I know a number in the sequence, I can find out where it was in the pattern. Okay, that's how we go back and forth. It was mentioned earlier, this models what kind of growth? This is all modeling linear growth. There's no exponent anywhere. It's a bunch of multiplying, adding, and subtracting. That's it. That's all we're doing today. Tomorrow might be more fun. Today, though, add, subtract, multiply. Okay. Now I'm talking about formulas. There are 2 different ones. Okay. There's an explicit formula and there's a recursive formula. So what we just did is the explicit formula. That's the most common one. There we go. Where we use A1 as the first term, and then we use D as the common difference. Okay. There is also a formula called the recursive formula. I think recurse, reverse. You can only use the recursive formula if you know what came just before it. Okay, so our recursive formula, see how it says A, to find my AN, I need AN minus 1. So to find my 4th term, I need my 3rd term. To find my 100th term, I need my 99th term. Okay, recurse, reverse. You have to go back one, and then you just add your difference. Right, so 2 different kinds, depending on what it's asking, depends on which one we're going to look for. All right, if the first term of an arithmetic sequence is a sub 0, so if they want to use a sub 0, which happens a lot in real-world context, it shows like something hasn't happened yet. That's my starting value, okay? What is the value of n for the first term? N equals 0. Nothing's happened yet. You haven't added a difference or subtracted a difference. Nothing has occurred. Okay? So this happens a lot in real world stuff. We started with this much and now I'm selling, 5 donuts a day. Then my difference happens. So real world stuff typically uses a sub 0. So if my first term is a 0, then how would I say my second term? I would do a with a sub what? I would use a sub 1 for my second term. Which means n equals 1. Okay. So lots of talk and like random examples of different things. Now let's put it to use. Okay? Let's make our math make sense. So here we go. We got Hans over here. Hans starts a new job at the Millennium Shack. His boss starts employees at a minimum wage of $7.25 an hour. However, the boss believes in rewarding good employees for good performance. If employees are on time, there we go, I can talk. If employees are on time for each shift and receive no customer complaints, the boss guarantees them a 10-cent increase each quarter. Okay? So what is Hans' starting hourly rate the first day of work? His very first day, what's he making? $7.25. All right, let's say Hans did awesome. He was on time, had no complaints. Okay, what is his new hourly rate going to be after the first quarter? $7.35 an hour, right? So let's say he did awesome his entire first year, okay? And he got his increase each quarter. We're going to use an arithmetic sequence to represent his hourly rate that first year. So let's make the sequence. So we already know the first one. What's the first one? $7.25. After his first quarter, what was it? $7.35. After his second quarter, $7.45. How many quarters am I going to go, by the way? I'm going to go 4 quarters. Good, that was 2. My third quarter, $7.55. And my fourth quarter, $7.65. Okay. So did we use a 0 or a 1 technically for my first term? Technically, we used a 0, right? Because this was after the first quarter, the second quarter, the third quarter, and the fourth quarter, right? So our very first value, this is what I was trying to kind of explain without giving it away. In a real world, it's usually the starting value of something before we add our difference. Okay. I have the description there for you again, so you don't have to keep flipping back and forth. Now I want you to write the explicit formula to represent Hans's hourly rate after n quarters. So we don't know how many quarters. It specifies the explicit formula. So that's where we have a sub n equals our first term, right? Where is it? Our first term plus n minus 1 times our difference. So how are we going to represent any term? A sub n equals what? 7.25. So yeah, technically that should be an A0, right? 7.25. Then what? Plus n minus 1 times. And what was our d? Nope. Almost. What was the difference each time? The difference was the 10 cents. There you go. All right. Let's write the recursive formula for any quarter. Okay, the recursive formula. So that's recurse, reverse. We got to go behind, right? So to find any piece, excuse me. Hold on, I got to go back. Here we go. AN equals AN minus 1 plus D. So AN equals AN minus 1 plus my 10 cents. All right, explain how the explicit formula for of A sub 0, how's it going to be different if we use A0 versus A1?
His first quarter couldn't exist essentially, and his pay started at 7.35.
Right. Yes. Did y'all hear what he said? Say it one more time.
His first quarter didn't exist, so it was 7.35 that he started.
Good. So if we started at A1, then his first quarter didn't exist, or he didn't get the raise for his first quarter, right? So the reason why we use A0 is because we need to represent nothing's happened yet. Okay, so when, I'm trying to put it in words, when A0 is first, okay, you get $7.25 as the starting rate. Excuse me. All right, the recursive formula. So technically up here, would I plug in a 0 up here? Would I say a sub 0 equals a sub negative 1 plus 0.10? Would that make sense for this real world situation? No, but it makes sense. We're not going to go back in time. So if I jump them up, if I made this n plus 1, like this, wouldn't that make more sense? Right? If I add 1 after my first quarter, I take my beginning amount and then add 10 cents. See how that the notation makes more sense that way? Okay, in real world context. So here, instead of adding the comma difference to a n minus 1, we want to add it to a sub n because we're already having a starting value. We can't go back in time. Okay, essentially a n sub 1, when a sub 0 is first, is representing negative time. Okay, so to keep it applying to our real world stuff, we need to represent a n plus 1 as moving forward and using a sub n as the first term because we're using 0. We don't want to go back in time ever. Okay. Let's do some more. That's going to help our math make sense if we keep practicing more and more. Our next two are not real world stuff, okay? It's going to be, here's the number, here's the sequence, black and white. Here we go. Consider an arithmetic sequence where a sub 10 equals 17 and a sub 18 equals 30, okay? And the first term of the sequence is being represented as a sub 1. All right, find the common difference. Okay, so to get from the 10th term to the 18th term, how many spaces did we go? We went 8 terms, right? Are y'all okay with that? Yes, right? 10, 11, 12, 13, 14, 15, 16, 17, 18, right? We started here. We got to 30. Okay. So what's the difference between the values? What's 30 minus 17? Okay. So we went 13 values, and how many steps? 1, 2, 3, 4, 5, 6, 7, 8. So what's 13 divided by 8? 1.625? Is that what you said? Okay. This is our difference. That was very much like a slope almost that we just found, okay? The common rate. So now it wants you to write the recursive formula for the sequence. So recurse, reverse, right? To find any number in this sequence, we have to use the one before it. Am I allowed to use this, or did I have to change it like the last one? Because it told me my first sequence was a sub 1, we're good to go. If they told me specifically it was A0, we'd have to change this so we didn't go backwards. Okay? So to find any term, we're going to take the previous term and do what to it? What's the pattern? we're adding the 1.625. All right, part C. Find the first term of the sequence. Can I use the recursive formula to find the first term in the sequence? No, that's not really going to help me, is it? Because I would need the second term to find the first term. So what I just created is not going to help me. What do I have to use instead? The explicit, okay? And we have two values that I can use. I can use A10 equals 17, or I can use A18 equals 30 to plug into our formula to find the first piece. So we're going to use this guy, right? A sub 1 plus n minus 1 times d. We want to know what is the first term, so we're going to plug in what we know. Do you want to use the 10th term or the 18th term? 10th term? Sounds great. So to get to our 10th term, we took our first, which we don't know right now, and we added to that 10 minus 1 times d, which is 1.625. What else do I know? What was the 10th term? 17. So I did all that to figure out that it was the 17. The value was 17. Can you solve for A1? Like we did earlier? Distribute, subtract. Try it. You try. Did you get 2.375 for your first term? All right, so now we're going to write the explicit formula because now I can, because I have the first term. So to find any term in the sequence, okay, I need my first term, which now I know is 2.375. We're going to add to that whatever term we're looking for minus 1, and we're going to multiply it by the difference of 1.625. So in order to write the explicit formula, you have to know your first term and you have to know your difference, because then you can find anything along the sequence. All right. How's our second one a tad bit different? Once we find the common difference between the two. Find the common difference in the arithmetic sequence if a sub 23 is 6a plus 7 and a sub 25 is 2a plus 1. Who has an idea? Okay, just because there's a variable in there, let's do it the same way we did before. How did 6a become 2a? We went down 4, right? Down 4a. How did 7 become a 1? It went down 6. And then how many steps did that happen? If I went from the 23rd to the 25th, that happened in 2 steps, right? So I'm going to divide it by how many steps it took. So my common difference is going to be negative 2a minus 3. Good. You're essentially finding the slope of the linear model, okay? Rise over run, how does it change over how many steps we took to get there? All right, now let's do 2 real-world examples, okay? Jamil deposited $20,000 in an investment account that will yield $1,750 growth for each year his money stays in the account. Looks familiar, doesn't it? Like we kind of did stuff with the finances last week. See how it's being tied together? Write an explicit formula for the sequence. Okay, so to find any term in the sequence, what do I need to know? You need to know what you started with. What did you start with? You started with $20,000. We're going to add to that n minus 1 times what was the difference?
1,750.
There you go. Yep, the 1750. All right, now use that to figure out how much money will he have in his account by the end of year 8 if he doesn't touch the account after his initial deposit. So figure out how much will he have after year 8. What'd you get? 35? I did not get 35. I got 32. 250 specifically? Okay. Yeah, I got $32,250. So you plugged in your 8 for your N. Oh, okay. Yeah, make sure it's a -1 rather. We okay? Tying the two things together? Here we go. In his piggy bank, Kirk dropped $1 on May 1st, $1.60 on May 2nd, $2.20 on May 3rd, and so on until the last day of May. Okay. My first question, well, what formula is happening? Let's start there before I start answering questions. To find any part of my formula, how much money did he drop in first? The $1, right? What is the difference? What is he? There you go, 60 cents. Good. Because part A wants me to, it's finding a different piece of the sequence, so I need to know the formula before I can answer that question. Okay. How much money did Kirk drop into his piggy bank? Oh my gosh. Piggy bank, there we go, on May 19th. So what does it want me to do? Plug it in for what? For my N. Yes, my N is now going to be 18. So my 19. My 19th day, right? No, my 19th day, 1 plus 19 minus 1, 0.60. So on May 19th, what did he drop into his piggy bank? Okay. Anybody else match that answer? He got $11.80? Yes, we match. Good. He dropped in $11.80. How much more did he drop into his piggy bank on the last day of May than he did the first day of May? Okay, so we know May 1st he dropped in $1, right? Before I can answer this question, I got to figure out the last day of May. How many days are in May? 31. So you have to figure out A sub 31 first. That's the last day. What did he drop on the last day?
$30. Or he dropped $31.46. The difference is $30.
That's not what I had. Okay.
Oh shoot, I forgot.
Okay. I got a nice whole number. Did you get a nice whole number?
Yes.
Yes? Did you get $19? Okay. Making me nervous, kids. So on May 31st, he should have dropped $19. Is that what it's asking me? No, it wants to know what's the difference. So how much more did he drop? He dropped $18 more. On May 31st. Good. We're not doing series, but if you've heard of series or you hear of series in the future, a series question would have been, what was the total amount he has in his account at the end of the month, where you would add up each day. That's considered a series question, which is not part of our standards anymore, unfortunately. I know you're sad. But what a great bonus question, right? Am I right? Maybe. Hint, hint, wink, wink. That might be a good bonus question. So you have to find each day and then add them all up. Okay, let's see if you're paying attention. Let's do some vocab. You ready? Here we go. A new iPhone cost $1,149. Its value depreciates 40% each year on a straight line depreciation. So let's complete the statement. A line changes at a constant or varied. A constant rate. Therefore, if the value of an object changes on a straight line depreciation, that means the value will decrease by a constant amount. Straight line depreciation, most models, ooh, there you go. Bringing it all together, simple interest. So let's figure out the value of all your phones, or the not value of all your phones. Let's see. How many of y'all have an iPhone in this room? Yep. Guess what? It's not worth nothing. Let's see. So, years after purchase, we're going to find the value after each year. Okay? So, after your first year, how much is it worth? What do I need to do? What is it? There you go. So, you're going to take away 40% of its value. Does that make sense? So what is 40% of 1149? Okay, if you take that away from our initial value, how much is it worth after 1 year?
$689.40.
What happens after the second year? Huh? Okay, what is it after year 2? I'm getting to that. 229.80. And how about year 3? Negative 229.80. So what does that mean? Yeah, what does that mean to go negative? It means iPhones lose, I can't spell, lose all their value before it's 3 years old. Think about how often they create new iPhones, or just cell phones in general. Don't they come out about every 2-3 years? A new one? I mean, yeah, iPhones, I feel like they're every year, yeah. Do your phones start messing up after year 2? It knows there's something better. It wants you to go get it, okay? If we were to use one of our equations for this one, okay, we could use the reverse formula, recurse reverse, okay? We could do, where is it? N equals A, N minus 1, and then what was it? Plus 1149. We could use, technically you were using your recursive formula. Okay, that's not right. I'm trying to rush because the bell's ringing. Yes, I'm trying to rush. You were doing 40% of the initial value. Yes. Hold on. Let me get this down. Okay, our initial value. We took away from it 40% of that value. Is that correct? Is that what y'all did? So we subtracted initial value times 40%. That's how we kept moving forward. All right.